All right, we're going to start a new video. This is section 5.3 in Algebra 2, and this is specifically factoring quadratic expressions. So still dealing with quadratics and that family of functions and expressions. This is day 1 on 5.3. We do have another skill that's fundamentally super related to this, but I feel like in my experience, it's better to focus on the factoring part for a while. Just to give you a heads up, day 2 is using the factoring to solve equations. So expressions here implies that we're not dealing with equal signs. We're just manipulating these sort of math phrases and writing them in a different way. All right, but they're going to be equivalent expressions, but we're going to factor them. All right, so here's the notes page. I realize that these are. Oh wait, first kudos to the class and for finding my mistake in the last video. Awesome. I'm so glad. It implies that you're not just copying down what I'm saying, but actually thinking as well. So I'm glad you're thinking. It makes me happy. Warms my heart. All right, so here's the notes page. Hopefully you already have this. This is day 1, and in our essential questions, this is what we're dealing with, the factoring of quadratic expressions. And like I said, this leads to day 2, the second essential question. And here, when we solve equations, right? Equations means there's going to be an equal sign. Expressions, no equal sign, right? There's not going to be an equal sign in these. Yeah. So let's just talk about what factoring is to start off. Good context. Let me zoom in a little bit. I know these videos are a little bit yellow, or at least they seem that way. I can't get enough light. I don't have enough lamps in my hotel room. That's okay. I think it's still visible. All right, so in the warm-up. All right, let's start with some prerequisite skills. Why don't you take a little bit of time and maybe just a couple minutes, no longer, a couple minutes, attempt these, and after you've finished all 6, done the best that you can, go ahead and take a peek and talk with someone sitting right next to you, with a partner, and compare answers. So I'll give you just like I said, 2 minutes to try these. All right, so a couple of minutes later, here we are. I'll go ahead and go through these, show you the answers, and also think out loud about my process. All right, so here we're going to list the factors of each number. So factors are the things that integers that can be multiplied together to get this number 10, for example, as a result. So, or the things that divide, another way to think about it in the other direction is things that divide evenly into 10 and give you another integer as a result. So factors of 10, anything itself and 1 are always 2 factors. So I can say 1 and 10. I'm gonna leave a little space because I'm gonna put these in order for no reason, just because. And so 1 and 10 make 10, and the other factors would be 2 and 5. All right, so we have 4 factors for the number 10. The number 48, that's going to have quite a few. This is kind of a messy one, actually, if you get factoring with 48 in this type of problem. That's okay. Just lots of options. So 48 has 1 and 48. I guess this time I won't write them in order. I'll put them next to each other as pairs. So 1 times 48 is 48. It's an even number, so I know 2 is part of this. 2 and half of 48 is 24. So 2 times 24 would give me 48. What about 3? 3 also goes into 48. 3 times 16. And finally, maybe not finally. No, there's more. 4 and 12. 4 times 12, definitely. And 5 doesn't work. 6 does. 6 and 8. Holy cow. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 different factors for 48. So no wonder this gets there's a lot of options when we have to deal with factoring 48 in upcoming problems. All right, C, 7. Numbers that go into 7. The number 7 itself and 1. This has a special math word. Actually, these do too. Numbers that are only factorable or divisible by themselves in 1, or they're only factors of themselves or 1, are called prime. And if this is defined, there's probably a vocabulary word for this one. I just learned this one without looking it up a couple years ago. So I didn't remember this as an Algebra 2 student. These are called composite. Composite numbers are composed of more than just the factors of themselves and 1. Okay, I'm doing this kind of quickly, so I can't decide if it's a good thing if I make a mistake or a bad thing. I won't do it on purpose, I'll tell you that. I promise you I will not do it on purpose, but still, you should be looking hard and questioning things that don't quite make sense in case I do. All right, so let's go ahead and look at the next one. We're going to look at the greatest common factor. Shorthand is GCF, so we'll see that quite a bit, of each set of numbers. So 6 and 14, I'm thinking to myself, what number, so a way to say this. What is the largest factor, greatest factor that these two have in common? So they're both, this one has factors of 2 and 3 and 6 and 1. And this has factors of 14 and 1 and 2 and 7. It looks like the only common factor besides 1 would be these two. So 2 is going to be the greatest common factor of 6 and 14. All right, so on this one, 12, 18, and 30, what number can I divide into all three of these? And it's the largest number, right? So 2 works for sure. 2 is a common factor. They're all even. That works. 3 works as well. Oh, and if 2 and 3 both work, then 6 has to work too, but I'll just double check that. 12 divided by 6 is 2. 18 divided by 6 is 3. 30 divided by 6 is 5. Yeah, so 6. I'll try to climb up a bit and see if I can go any further. No, that's it. So 6 is going to be my greatest common factor here. All right, so let's look at C. Numbers that go into 4, 2 and 2, 4 and 1, 8 and 1, 4 and 2. So 4, these two have 4 in common. But this one is odd. So this one doesn't have 2 or 4 in common. This is just 1 and 5 and 3 and 15. Because this is odd, I think we are stuck. I think the greatest common factor for these is 1. And if I made a list of all the factors, the only number that's on all 3 lists is the number 1. So that's the only common factor, so it has to be the greatest. All right, so that's just a little background on what a factor is when we're dealing with just discrete, knowable values. And that's going to play a big part in the factoring we do coming up. So here's a nice way to think about factoring and a good skill to pick up. So the opposite of factoring. So what's the opposite of dividing out all of these numbers? Okay. The opposite of factoring is multiplying, right? So if you're looking at what divides into it, then the opposite would be multiplying it together. So we can check our work, using multiplication properties and specifically the distributive property. Okay. And the multiplication, I'll say the operation of multiplication, which is nice, right? So I can always check my work to make sure I'm dealing with factors by just multiplying what I think are factors together and see if it brings me back to the same place that I started. All right, so we're already 10 minutes in. All right, so in this case, we're gonna get, let me just peek, 1, 2, looks like 4 levels of factoring. And I start with the ones that are the most straightforward and hopefully build into more challenging ones. One of the most challenging parts of factoring in my experience is for students to practice enough that they get comfortable with figuring out which method they should use. And that only comes with some practice and kind of struggling with a concept, whether it's level 2 or 3 or whatever it is for you individually as a student. But you have to kind of work through those things, and then you'll get a better perspective on which factoring method you should use given the situation. So this first one, level 1, it's the GCF. And I say always try this first. This is the first thing you should do because it can often simplify harder problems. It's strange for me to say this over video where you can't see me and tell that I'm kidding, but just know that I'm like winking and kidding. I'm saying this. So, right. So your parents know I'm kidding, but I call this stealing. So I think you should steal first and whenever possible. Okay. So if you choose to say those things about Mr. Keller advising that you steal whenever possible and as soon as you can, I understand you might leave the context out, but I have this video to back me up that it was in the context of factoring, but steal. Okay, so I think you should steal. Steal first. All right, so stealing is, what do these two terms have in common? What are some factors that I can pull out of both of these terms? So I always start with the numbers first. So let's just focus on the 8 and the negative 20. What is the greatest common factor of 8 and 20? Let's see. 4 goes into both of these. All right, so 4. And then if I look at the second piece, the variable piece, do these have a variable in common? In this case, they do. This has x times x, the first term, and the second term has one of those x's. So if I can steal one from each. So I can steal a 4 and an x from both terms. And what I'm left with, right, this is where it looks like the opposite of the distributive property. 4x times 2x would give me 8x squared. And 4x times a negative 5 would give me negative 20x. So I can check, as I said, using the distributive property. So 4x times 2x is 8x squared. 4x times negative 5 is negative 20x. It looks the same as where I started, so I know that I'm in good shape there. And if you're really not sure, you can look, because sometimes you take something out that's not the biggest, you can look at what's left and see if these things have any other factors in common. 2 and 5, those don't have anything in common besides a factor of 1, so we're good. All right, next one. Same question. What do these two terms have in common? Well, they're both negative, right? So I can take out a negative for sure. And these are both divisible by 3. A 6 and a 3 both have 3 as a factor. So I can steal a 3. So I'm stealing a negative 3 so far. That's the coefficient and the constant, right? The number term. So now look at the variables. In this case, only the first one has any variable factors. So I can't steal anything else. So what I'm left with is, let's see, negative 3 times a positive 2x squared, I think would give me this, and a negative 3 times a positive 1 would give me the second term. This is an easy thing to forget, that when you divide out, you still have a 1 left over. So especially in times like this, it's great to check to make sure you're on the right track. So negative 3 times 2x squared, negative 6x squared, and negative 3 times 1 is negative 3. This looks the same as this, so I'm saying that's good. Box my answer and move on. Notice how I checked, looks the same. Great. All right, so I think look at C is a really interesting one. It's probably new for most of us. I think our tendency here is to distribute. Right? You see parentheses, and we're in this habit of, when I solve equations, I distribute and get rid of the parentheses, and then I can combine like terms and do all this stuff. In this case, we are not going to do that. We're not trying to solve an equation. We're trying to factor out things that are in both terms. And this one is very visual, right? I see this x plus 1 in both terms, right? Here's term number 1, term number 2, separated by either adding or subtracting. In this case, subtracting. So I can take out x plus 1 from both of these terms. I could do little arrows here that say, you know what, this is the opposite of the distributive property. I'm stealing them, right? I just stole those from both terms. So now what's left in the first one is a 2x, and in the second term is a negative 3. So we're going to check this the same way. I'm going to take this whole piece here, and I'm going to distribute it back in. So x plus 1 times 2x, x plus 1 times a negative 3, right? And yeah, this is out of order, but let's multiply in parentheses. You can just rearrange the order. You're multiplying two things, it doesn't matter the order. 2 times 3 is the same as 3 times 2. 5 times 8 is the same as 8 times 5. So it's the commutative property. We can switch this around. This is the same as this. Negative 3 times x plus 1 is the same as this. So this is the same. This is an important piece of a harder concept later, where this is a phase, right? We get it to this stage, and then it's called factoring by grouping, because you're stealing like this group in parentheses. All right. So there's our first set. Let's go ahead and take a look at level 2. I will give you a chance to do some U-try-its in a little bit, but let's go ahead and look at level 2. All right, you've probably seen this before. In fact, I'm almost sure that you have, but that doesn't mean you remember all of it. That's not the nature of how our brains work. So let's review. So level 2 is when a equals 1. So that, remember, ABCs. A here would be 1, B would be 8, and C would be 15 in example A. So notice in all of these, let's just take a look real quick. A equals 1 in example A equals 1 in the next example, and A equals 1 in the last example. So maybe let's write a 1 in there. All right. Okay, so maybe I'll just tell you what the answer is. All right, the answer here is, and we'll work backwards. The answer here is x plus 5 times x plus 3. These are more complicated because we have two binomials as our result, as the factors. But let me go ahead and show you the distributive property, and maybe we'll have a better idea of how to work it backwards. So we're comfortable, I think, with this. If I gave you this as a problem, you could distribute the x to both pieces in the second binomial, and then distribute the 5 to both pieces in the second binomial, and then combine like terms. All right, so I gave you the answer, but that's not the point. The point is, let's work it backwards now. So notice that in the answer here, right, which now becomes the question in our new style of problem, this 15 is from multiplying two constants. And this middle term, the b term, in this case 8, comes from adding the two constants, right? X times 3 is 3x, 5 times x is 5x, and then we added them. So this is the pattern. So my process, when I'm trying to break this down and go backwards, is I look at the 15 c value, I look at factors of c. So I'll just make a list like we did in the warm-up. 15 and 1, 5 and 3, and then don't forget, negative times a negative is also a positive. So these are the different pairs of factors that positive 15 has. Now I can look at my list, and instead of all the possible numbers in the world, which there's so many, I can look at my list and decide which of these adds up to a positive 8. This one adds up to 16. This is the one that adds to positive 8, but I'll just double check the others. This is negative 16, and this last pair is negative 8 when I add them. So this is the good one. So here's my structure. Oops, I'll put the 5 first. No reason really, except that I wrote it first earlier. And there are my pair of binomials that are factored. So this, I think, is my answer. I'm going to check it. Oh, wait, I already did. I already have the answer. I forgot. I have the answer over there. So here it is. Awesome. But this is how you check. Check it with the double distributive property. Excuse me. All right, next one. So here, right, my C is negative 25. These all have A equals 1. And my B value is 0. So I need things that multiply to negative 25 and add to 0. So my factors of negative 25, my C, are negative 25 and 1, 25 and negative 1, negative 5 and 5, and then the same, negative 5 and 5. When I make my list, I can see pretty quickly that these are the ones that add to b, which in this case is 0. So these are my 2. I have x plus 5 times x minus 5. Okay, third example in this final set. A is equal to 1, so this is my pattern I'm using. You have to check with that first. Can I steal anything? I forgot. We're supposed to be doing that first. Can't steal anything because A is 1. Anyway, so I can't do anything there, so I'm going to focus on factors of C. Take a look at my list. Got 12 times 1, negative 12 times negative 1, 6 times 2, negative 6 times negative 2, 4 times 3, negative 4 times negative 3, and those are all of my factors. Which of these adds to negative 7? It just happened to be the last one. So my structure here would be x minus 4 times x minus 3, and then I can check using the double distributive property. X times x is x squared. X times negative 3 is negative 3x. I'm running out of space. I'll just come down a little bit. Negative 4 times x is negative 4x, and negative 4 times negative 3 is a positive 12. One of the really common errors in this process is a sign error. A sign error will tell you that a right answer is wrong or lead you down the wrong road. So it's important to be really cognizant, careful, focused, and diligent when it comes to sign agreement, sign errors, and things like that. So when I now combine like terms on this part that I'm checking, I get this x squared minus 7x plus 12, which is the same as the original problem. Awesome. That's it. So this is me checking it. Don't put a box around that. This is the answer. Factors. Things that multiply together to get what we were trying to factor. All right. So I think I'll pause it right there because I'm at about 22 minutes. And we'll look at the next set where we build on these skills and something a little bit tougher, but totally within what you're capable of doing for our next set of factoring.